don't think we watched that. Good afternoon. Good afternoon. How's everybody? Hope you stay keeping warm this cold, cold area. I mean, cold, cold day. I spent the morning taking the ice shell off my car this morning. It was totally encrusted with ice. Okay. We are moving on to Cancer today. Most of you still have several, at least two assignments that you need to turn in. Giving it a minute, just get everybody in before I continue. But from what I can tell from the grade book, most of you still need to turn in meiosis and genetic defects. Only a handful of you have completed both. More of you have completed none. And we are moving on to Cancer. So we don't want you to start falling behind. So take a few minutes to look at what you might be missing. Tutorials have started back up. I'm available for extra help on Tuesdays and Fridays at the end of the day. So if you need extra help, please make you just show up on Tuesdays or Friday and into the Zoom. Don't worry about trying to sign up because that portal thing doesn't work. So just let me know that you are interested in showing up for tutorial and I will be there. I'm usually there anyway, so just come. All right, so again, while we're waiting on folks to come in, because we are missing about 4 people or so, um, please look at the assignments that you already have. Like I said, most of you still have to do my Cells Alive. Hi, how you doing? So Cells Alive, Meiosis Cells Alive, and Genetic Defects. Those are 2 worksheets that most of you still have outstanding. Um, I am adding the cancer worksheet to it today because that's what we are going to do today. Okay. All right, so like I said, I'm gonna give it another minute or so, and then we're gonna watch a short video, and I will direct you to the assignment that goes with it. But if you are one of the four people who have completed both assignments that are outstanding, please take a look at the cancer lesson in the Canvas. All right, so again, if you are finished with the two assignments that are outstanding, please read up on cancer, the C word. Again, most of you need to look at your meiosis review page and your um, genetic defects assignment. Both of those are outstanding for most of you. Okay, and I might add also that next week progress reports go out. You want to make sure that all your grades are up to date so that when the progress report's available, that it is reflecting accurately reflecting your grade. All right. Let's see. We'll give it 2 more minutes. All right. Desiana, if there's anything I can help you with, because I know you've been absent for a minute, but please check the assignments that are outstanding. Okay. Okay, I was saying, please check your outstanding assignments. I know you've been out for a little while. If there's anything I can help you get caught up on, just let me know. Good afternoon. We're getting ready to look at the unit on cancer. All right, everybody else is just late. I'm going to go ahead and get started. Uh, all right, so the C word, that's one of those words that nobody wants to hear. That's why they call it the C word. But we're going to look at what cancer is, what cancer isn't, and then there is a worksheet that you will do.
The onset of cancer usually begins as a solitary tumor in a specific area of the body. If the tumor is not removed, cancer has the ability to spread to nearby organs, as well as places far away from the origin, such as the brain. So how does cancer move to new areas, and why are some organs more likely to get infected than others? The process of cancer spreading across the body is known as metastasis. It begins when cancer cells from the initial tumor invade nearby normal tissue. As the cells proliferate, they spread via one of the three common routes of metastasis: transcoelomic, lymphatic, or hematogenous spread. In transcoelomic spread, malignant cells penetrate the covering surfaces of cavities in our body. These surfaces are known as peritoneum and serve as walls to segment the body cavity. Malignant cells in ovarian cancer, for example, spread through peritoneum, which connects the ovary to the liver, resulting in metastasis on the liver surface. Next, cancerous cells invade blood vessels when they undergo hematogenous spread. As there are blood vessels almost everywhere in the body, malignant cells utilize this to reach more distant parts of the body. Finally, lymphatic spread occurs when the cancer invades the lymph nodes and travels to other parts of the body via the lymphatic system. As this system drains many parts of the body, it also provides a large network for the cancer. In addition, the lymphatic vessels empty into the blood circulation, allowing the malignant cells to undergo hematogenous spread. Once at a new site, the cells once again undergo proliferation and form small tumors known as micrometastases. These small tumors then grow into full-fledged tumors and complete the metastatic process. Different cancers have been known to have specific sites of metastasis. For example, prostate cancer commonly metastasizes to the bone, while colon cancer metastasizes to the liver. Various theories have been proposed to explain the migration pattern of malignant cells. Of particular interest are two conflicting theories. Stephen Paget, an English surgeon, came up with the seed and soil theory of metastasis. The seed and soil theory stated that cancer cells die easily in the wrong microenvironment. Hence, they only metastasize to a location with similar characteristics. However, James Ewing, the first professor of pathology at Cornell University, challenged the seed and soil theory and proposed that the site of metastasis was determined by the location of the vascular and lymphatic channels which drain the primary tumor. Patients with primary tumors that were drained by vessels leading to the lung would eventually develop lung metastases. Today, we know that both theories contain valuable truths, yet the full story of metastasis is much more complicated than either of the two proposed theories. Factors like the cancer cell's properties and the effectiveness of the immune system in eliminating the cancer cells also play a role in determining the success of metastasis. Unfortunately, many questions about metastasis remain unanswered till today. Understanding the exact mechanism holds an important key to finding a cure for advanced stage cancers. By studying both the genetic and environmental factors which contribute to successful metastasis, we can pinpoint ways to shut down the process. The war against cancer is a constant struggle, and scientists are hard at work developing new methods against metastasis. Of recent interest is immunotherapy, a modality which involves harnessing the power of the immune system to destroy the migrating cells. This can be done in different ways, such as training immune cells to recognize cancerous cells via vaccines. The growth and activity of the immune cells can also be stimulated by injecting man-made interleukins, chemicals which are usually secreted by the immune cells of the body. These two treatments are only the tip of the iceberg. With the collaborated research efforts of governments, companies, and scientists, perhaps the process of metastasis will be stopped for good.
Okay. So that is in your playlist. All right. All right, so getting back to the lesson today on cancer. All right, so again, if you're going to the cancer doctor, he would be the oncologist.
How does a gene that causes cancer, known as an oncogene, work? Cells have genes that direct the formation of receptor molecules. Receptor molecules are like antennae, sitting on the cell surface. When they receive growth signals from the outside, they send a message to the cell nucleus that it's time to divide. The oncogene causes a slight difference in the receptor molecule. Like an accelerator pedal stuck permanently to the floor, the receptor keeps signaling the cell to divide, whether or not the receptor is getting that message. The more oncogenes there are, the more receptors present that are sending a stream of signals for the cell to reproduce. But how does cancer spread? How do cells escape into a person's bloodstream and attach themselves in other parts of the body? First, the cells fasten to the membrane around the blood vessel. Then they use a strong chemical to work their way through the tough membrane into the circulatory system, which carries them to new tissues and organs. Scientists understand the molecules that accompany each of these steps and are trying to develop drugs to stop them. Other therapies are aimed at shutting down the receptor molecules to stop the cancer from growing.
All right. So again, cancer is uncontrolled growth, cells that just keep reproducing uncontrollably, but they do so in one spot. So they eventually create a tumor. And sometimes the tumor gets in the bloodstream, as the other video is explaining, and it travels to a new location. I personally know someone who started with prostate cancer. They thought it was cured, but it had metastasized to bone cancer. And when you get bone cancer, that's very, very serious. And they did not survive. All right. All right, so there's a worksheet that is attached. So I want you to go through and read, like again, those of you who are finished with everything that is before. And again, folks, this, keep saying this is a end of course test class. Some of you are just sitting back, signing in and not doing any work, and we're going to keep on going, which means you're going to keep on falling behind and falling behind because you're not using class time for class work, or you show up halfway through class and still don't get the job done. Okay. Yeah, I'll help you in a minute, Chris. I'll tell you what that is. I know exactly which one you're talking about. All right, so at the end of this unit on cancer, yeah, I'm sorry to hear that. Cancer is an ugly disease. That's why they called it the C word. It is wonderful if they catch it early and they can cut it out and it doesn't spread. But if you don't, which is why going to the doctor is really important, so they can catch things early. People say they don't like going to the doctor. If you don't go to the doctor, they can't catch it early. And then once it spreads, it's hard to stop it. All right, so there is a worksheet. Some of this you will have to do a little Googling for. And again, if you use AI, do not just copy and paste. translate, abbreviate, but this is after you've read the unit on cancer. The next this is in the module, so just go to the next slide, the next lesson, and that the worksheet will be there. So do read how it mutates, and then complete the worksheet. All right, so that's, for some of you, that's 3 worksheets now. So again, please use class time to do classwork. All righty, stop sharing. Yeah, actually, let me pull up that worksheet on my meiosis. I did skip bacteria, not so much that I skipped it, in that we'll talk about it later, but it is bacterial cells are asexual reproduction. So we've mentioned these asexual reproduction, that there are different types of asexual reproduction. Bacteria grow asexually. So they just come under that heading of asexual reproduction. All right, so some of you have to do genetic defects, and then there is, some of you are still working on cells alive. All right, I'll pull that one up just again. And if I can get this to share. All right, so and there's a couple of you who haven't done it. So if you haven't done it, please pay attention. All right, on your worksheet, actually, let me see if I can get the worksheet to be side by side. When you look at the worksheet, the picture that is in the square is going to look exactly like the one on the worksheet. Okay. So if I'm clicking on the diploid cell and it says 2N, then the one on your worksheet is going to look just like this. And you got to remember, meiosis has 2 stages. So the first one is just going to have the 1 cell, and it's going to look like that. On your worksheet, when you click on prophase, the one that you're looking for on your worksheet will be a picture of 1 cell, and it'll look exactly like this one. So look at what's in the square before you look at, I'm trying to find my worksheet so that I can have it side by side here. Look at the picture in the square, and then click on the thing so that you can see what it says. You have, for this question, you have to put both the letter that matches the picture, as well as a brief statement about what's going on in this picture. Okay? All right, so diploid cell, and I told y'all diploid cell was F. F was a diploid cell. So for a diploid cell, you want to say that it already tells you that it's 2N, or if it doesn't, no, it tells you there it's 2N. You can put it's a 2N, send the chromosomes, duplicate and produce sister chromatids. That's all you really need to write on that line. Okay? So you need a letter. You need to match the letter with the word description, and you need a brief statement. All right, again, prophase, you're looking for the picture that looks like this on your paper. It looks exactly like this, the one in the square. Okay? Metaphase, it's going to look exactly like this on your paper. So look for the 1 cell. The 1 cell that looks exactly like this. Same thing with anaphase. It's still going to be 1 cell. It's going to look exactly like this. Telophase, it's going to start to separate into 2 cells, and that's meiosis 1. Prophase, you're going to have a picture of 2 cells, 2 distinct cells on the paper. So that's what you're looking for. Metaphase, the 2 distinct cells are going to have the bars lined up in the middle. Anaphase, they're going to start to pull apart. It will look exactly like this with picture of two cells doing this. Telophase is going to look exactly like this on your paper, where the chromatids are starting to move back towards the poles. And then this one is going to show you 4 cells. Okay. And again, for your descriptions, you want to keep clicking on the little eye so that you can match those, write a brief description on the line for which one is which. All right, so you're going to put the letter of the picture that matches the worksheet that matches with what's on the screen. Chris, did that help? Okay. All right. And like I said, there were several of you who have not done this worksheet, so I hope that helped you as well. Hope you were paying attention. All right. Um, all right, that was the link for that. Where'd the worksheet go? Why doesn't this have a... Okay, hold on. I don't know why that is switched to not being... I think that should be it. We'll know in a minute. Yeah, there we go. All right, so that's a link now. I don't know why it stopped being a link, but there we go. So these pictures look exactly like the picture on the website. So where there's 2 cells, it's going to be 2 cells in the picture. Where there's 1 cell, it's going to be 1 cell in the picture. This one is starting to divide to 2. This one is starting to divide to 4. It'll look exactly like that on the website. Student view. Okay.
What would this one be? I mean, I can't find it on the thing.
All right. Okay, I'm gonna stop sharing and then look at you and Go Guardian. Hold on. And when I look at Go Guardian, I want to see everybody working on something. All right.
I think it's one down below E.
All right, Chris, I'm looking at yours, and that one is G. The one you have on the screen right now is 1 cell. It's got the circle around it, and that is going to be G on your worksheet.
What'd you say? What a diploid cell do? What I can just put on the box?
Let me go back. Can you click back up there to diploid, and I can tell you, look at yours faster than I can look at mine. All right, click on the little eye on the side. Those little pink eyes to the, yeah. All right. See that last, or start from where it says DNA. Just say DNA chromosomes then duplicate and produce sister chromatids. That's all you got to say. So sometimes they give you a lot of information. You don't need to write everything that's there. Figure out what is the most important thing about what you're looking at, and then write that. I'm looking at a lot of people not doing anything at all, folks. I can't help you if you're not going to help yourself. Got one person who's been idle for 30 minutes. Another one idle for 10 minutes, 13 minutes. Okay. And Akari, I don't know why I always have to check because yours never shows up on Go Guardian. I have a tendency to mark you absent every time. Are you working on a different computer, not your Chromebook or something? Is that what it is?
Yeah, these pictures confuse me.
Okay, give me 1 minute to finish doing attendance.
All right. Okay. All right, I'm gonna pull it back up. See if I can get the worksheet up first.
All right, folks. And again, those of you who have not done the worksheet, please pay attention. Okay, on your worksheet, and like I said, I'm going to tell you the first one is the diploid cell, and the diploid cell is F. So, and I can't circle it, but this is the dip. Let me change on my screen so I can make sure you see what right. All right. So that you can see my arrow going round and round. It's going to look exactly like that on the animation. So when you click diploid cell, you click the word diploid cell. Oops. Am I on meiosis? I'm on mitosis. Hold on. Oh, meiosis. It's showing you a cell. Wait a second. Hold on. Okay. It's this might be the only one that's not as clear as it is on the interactive, but it kind of is where there it is. Okay, that looks exactly like your worksheet. Okay, and then all you have to do is write the important part, right? It's a 2N because there are 2N in a diploid cell, and it tells you 2N up here next to diploid cell. So write 2N, and then all you need to write down here is the DNA chromosome, duplicate, and produce sister chromatids. So that's what they have done. Okay, so but all of these are double. They duplicated and they produce sister chromatids. All right, next one, prophase. On your paper, it's going to look just like that. So let's find that one. That one is G. So you want to put G on the line up here. And again, it is one cell. It's a picture of one cell because we're in meiosis 1. It hasn't divided to make the 2 yet. Okay. And again, you figure out what you need to write by shortening whatever is going on in that phrase. Metaphase, remember the things that the chromosomes are going to be in the middle. Metaphase middle. So on your worksheet, you want to find the picture where they are in the middle. They're in the middle. Okay. And then you want to come back and click on the dot and write down what is happening in that picture. Anaphase, they're starting to pull apart. Remember A apart, anaphase apart. They're starting to pull apart.
So which one does metaphase look like on the worksheet?
Metaphase is going to look with they're in the middle. The chromosomes are in the middle. Remember, M is for middle. Metaphase is middle. So the chromosomes are going to be in.
I'm looking at it and it looks like D.
Yes. The one I'm circling on. Can you not see my arrow running around the I got an arrow. Can y'all not see that arrow?
I have a little bad eyesight, and I'm trying to look at all 3 screens at the same time.
Okay. Yes, it's D. And then the one that's pulling apart is going to be H. Anaphase apart H. And folks, if I'm giving you the answers, I surely hope that you're writing these down. All right, next one, telophase. And after they pulled apart, then this cell starts to divide. So our one cell is becoming 2 cells. And that's going to be this one down here, J. All right, the one cell is becoming 2 cells. Okay. All right. And then we have prophase. All right, prophase, we definitely have 2 cells and something is happening in those 2 cells. And that one is going to be the one that looks like this. And then metaphase, they're going to be lined up in the middle again, except this time it's 2 cells where they're lined up in the middle. So actually on your worksheet, they're kind of, these are in the middle, but there's just 2 cells in the middle. This is 1 cell in the middle. This is 2 cells in the middle. All right, anaphase, again, they're going to be pulling apart, but 2 cells pulling apart. Whoops, wrong one. Going this way. 2 cells where they're pulling apart. All right, so look at the difference between this one pulling apart and this one pulling apart. All right, telophase 2. All right, they're already pulled apart and it's starting to look like it's going to make 4 cells. That would be this one. They're pulling apart still and it's starting to look like 4 cells. And then the gametes, we definitely have 4 cells. So on your worksheet, and I think most of you got at least that one, right? Where you have the 4 cells. Okay? All right. So no excuse, folks. Hopefully you were doing this with me. And all you have to do is go back and put a description. Once you get the pictures lined up properly, go back and get a description. But again, they pretty much look like what it is on your worksheet. And just remember that meiosis, sometimes the pictures are showing you 1 cell when you're clicking over here, but just remember that in meiosis 2, you're dealing with 2 cells. Any other questions before I stop sharing? Okay, so by today, everybody needs to at least be finished with their meiosis worksheet. But we're about Wednesday, you need to be finished with the genetic one and working on cancer. Meiosis one is late after today. So please be working on that.
I can't figure this one out. The telophase.
Okay, you have it up on your screen.
I have everything up just for you.
Okay, yes, a sec. All right. So what do you want to know about that? That's telophase one.
Yeah, I'm trying to find the exact thing of it.
Click on the little eye. All right. On your worksheet, it'll look more like that. It's J.
Thank you.
Mm-hmm.
Yeah, unfortunately,
Huh?
I was talking to somebody else.
Okay. Okay, Nevaeh, I will check. I will check. Oh, and that's a reminder too, folks. Those of you who might not have done your mitosis worksheet, it's on the same website. Just click the words at the top of the page. And the same website, you can go from meiosis to mitosis and the same site. Hmm.
I can't. It's hard to find Prophase 2.
That's going to be the one with two cells, and they look like they're just getting. Look at my work. Oh, it's going to be prophase 2. Okay. It's going to be two cells. It's going to be A. Yeah, it's going to be A. So it's going to be two cells, but they haven't pulled apart yet.
Okay, thank you.
All right, folks, we got about 5 minutes left to class. So please make sure that you are working on getting at least your meiosis page done if you have not already done so.
I need help figuring metaphase 2. They're lined up together, and I only have certain options left.
It's the one on top of the other one. So there's B and D. D was metaphase 1, and B is going to be metaphase 2, where they're both lined up right in the middle.
They're gonna be what?
Lined up. Remember, metaphase M is for middle, so they're lined up in the middle.
Yeah. So it's I've already hefty. So
Yeah, D should have been metaphase 1,
yeah.
and B is metaphase 2.
I see. I see the same.
Okay. All right, folks, it is 1:30. And folks are starting to log in from my next class. Any last questions before you go? Before I go. All right, then. We'll see you next time, Wednesday. That's great. Getting caught up is a wonderful thing. All right, see you Wednesday.